Hello everyone, learn chemistry with Bookem. Today's topic is organic chemistry and subtopic is alkanes. So we'll be talking about alkanes and that is under organic chemistry. We have alkanes, we have alkynes, we have alcohol, we have alkanoic acid and all. But just today we're picking a topic from organic chemistry and this class is applicable for 10th to 12th grader. That means for 10th grade, for 11th grade, for 12th grade. So before we move on to alkanes, so we cannot discuss alkanes without talking about organic chemistry. So what is organic chemistry? Organic chemistry is the study of carbon and hydrogen with other compounds like oxygen, sulfur, halogens like the chlorine, the fluorine, the iodine, and the likes, and so on. Now that we know what organic chemistry is, what are alkanes? Alkanes are saturated hydrocarbon. They are saturated in that they only have single bonds in their structure. So let's look at an example is methane. Methane has a single bond in its structure. That's methane is CH4 and the structure is like this. So this is H, H, and H. So we can see that C is attached to only single bond. There's no double bond attached to that carbon. We can only see single. This is one single bond, another one here, another one here, another one here. So that is single bond. So that is called alkanes. So that is why alkanes are called saturated hydrocarbon. So alkanes has a general formula which is CnH2n plus 2. So this is the general formula for alkanes. So with this general formula, we can easily know the formula for each series of alkanes from methane to ethane up to decane. It will be easy for us to write any formula of alkanes with this general formula. Okay, so I'm going to teach you how to use this formula to write different series of alkanes. So okay, let's start with methane. You know methane, okay, alkanes has series from methane to decane. So methane has one carbon, ethane has two carbon, propane has three carbon. So let me start with methane. So I have the series here. But let's start from methane. Methane has one carbon. So if methane has one carbon, we are going to replace this N. Initially, the formula is CnH2n plus 2. This is the formula, and we know that this N is an unknown. So if we have methane, that means methane has one carbon. So if methane has one carbon, that means we are replacing this N with that one. That is, methane is on carbon. It has only one carbon, and methane, the series of methane under alkane is 1. Is arranged or is the first one in the series. So now we can now easily add 1 to this. We can easily make N subject of formula. We can substitute N with that one. So if you are substituting N with that one, we say C1H2. We can say N times 1 plus 2 plus 2. So this is 2. This is 2 plus 2. So that will give us C H 2 times 1, we have C. C1 is the same thing as writing normal, only C. So 2 times 1 is 2, plus 2, that's 4. So that's CH4. So that is how we got the formula for, so that's why methane is CH4. Butane is in the series 4. Butane is in series 4. Series 4, that is in position 4. Position 4 of the alkanes series is in position 4. So if it's in position 4, we know our general formula to be CnH2n plus 2. So we are representing N. Since we are dealing with butane has 4 carbon. So we are representing our N with 4. So that is 4. So we can easily substitute N into this formula to know the formula for butane. So let's do it. This is C. N is 4, H2, N, that's times 4 plus 2. That gives us C4, 4 times 2, 8, 8 plus 2, that's 10, C4H10. So this is the formula for butane. So we can do it for all, from methane to decane. Decane has carbon 10, so on your own you can try for N, you can try to you can substitute N with 10 and see what you are going to get in returns. So that is using the general formula. We can easily get using the general formula we can easily get all the series of alkanes. I have the series of alkanes here. I have the series of alkanes here. So the first one, you can see the first one is the methane. The second one is ethane, that's series 2, that's on number 2. It has 2 carbon. The third one is propane, butane, pentane up to decane. And you can see the general molecular formula, the condensed structure, and the number of possible isomers that each have. So on your own, you can easily learn this. You can write this down to easily learn it. Then you can also use the formula to predict any of this molecular formula or molecular weight. Okay, so now we have some examples of alkanes. Simplest alkanes are the methanes. Methanes are the simplest alkane: methane, ethane, and propane, and they are mostly found in our natural gas and petrol. Methane is the carbon one. Ethane is the carbon 2, has C2, has 2 carbon. Propane has 3 carbon. So they are mostly found in our natural gas and in petroleum. So the next topic is under alkanes is structure and bonding. So we can't discuss alkane without discussing the structure and bonding of alkanes. One atom form single covalent bond. So hydrogen doesn't have double covalent. Covalent bond is a bond that is formed between two non-metal. Covalent bond is a bond that is formed between two non-metal. An example is carbon and hydrogen. As you've done it, you can see alkanes consist of carbon and hydrogen, and the bond between this carbon and hydrogen is called a covalent bond. Alkanes Alkanes are tetrahedral in shape. Example, methane. Methane is tetrahedral. All alkanes are tetrahedral in shape. And this is the shape, this is how the shape of alkane, this is how the structure of alkane is being drawn. This is structure of alkane. And the bond between each of these hydrogen is 109.5 degree angle between each hydrogen in alkanes. And they are always tetrahedral. All alkanes are tetrahedral. The next one is each carbon makes 4 bonds. Each carbon makes 4 bonds. Carbon cannot have more than 4 bonds. Each carbon makes, can you see, this is one. For methane, as I've explained earlier, that methane cannot have more than 4 bonds. Normally, carbon cannot have more than 4 bonds. So this is an example using methane. Methane is CH4. You can see this is one H, another H, this is another H, this is another H. So carbon cannot have more than 4 bonds. In the case of double bond, it can also not have more than 4 bonds. If it's double bond, we have C double bond H. As we have C double bond like this, then the remaining hydrogen must be balanced. We must balance the remaining bond around carbon atom. So that's, we have 2 bonds here, 1, 2, 3, 4. This is 2 bonds, 1, 2. Since this is double bond, that's 2 bonds. This is 3 and this is 4. So we cannot have more than 4 bonds around carbon atom. So that is another thing about bonding and structure of alkanes. They cannot have more than 4 bonds. Or hydrocarbon or organic chemistry, organic compound cannot have more than 4 bonds. Okay, moving forward. And they form either straight chain. All alkanes form either a straight chain or a branch chain. So we have some example of a straight chain alkane, that is the normal alkanes. So these are the examples of the straight chain alkane. This is pentane. This is pentane, is an example of a straight chain alkane. Carbon here too. So this is pentane. It is a straight chain. It's a straight chain. Okay, why is it a straight chain alkane? The first one is pentane. Pentane is straight chain alkane because it is written in a straight chain form. Can you see? This is a straight chain form. You can see 1, 2, 3, 4, 5 pentane. This is a straight chain form of alkane. Another example is 2-methyl butane. It's still a straight chain form. It's just that there's a source. This is called a substituent. Don't worry, when we start the naming of alkane, you will understand the substituent better. So this is a straight chain alkane. This is called a straight chain alkane. So let's move to the next example. Let's move to the next one. So the next one is a branch chain. Example of an alkane. Another example of alkane is a branch chain. Okay, can you see a branch chain alkane? This is a branch chain alkane. You can see the difference. This is a pentane is not a branch chain. Isopentane. Isopentane is a branch chain alkane. Can you see? It's not just straight. There's branch. You can see there's an additional substituent making it look branch. Can we see it here too? New pentane. New pentane too is a branch chain alkane. It's looking enclosed. It's not in a straight chain form. It's not in a straight chain form. It's looking enclosed. So that is another example of a branch chain alkane. So we'll be stopping here for today. We'll be stopping here today. In our next class, we'll be talking about the nomenclature or the naming of alkane. Thank you for listening, and I look forward to see you in my next class. Thank you.